Yes, I am.
Oh, okay.
So have I started the recording?
Yes, you can start the recorder.
Yeah, the recording has already been started. So good evening, everyone. Welcome to today's session. So today's session is uh, about the continuation of what we have already started about classes. And in the previous class, we discussed how to declare classes and what class is. So today we are going to continue from where we stopped. I think last week we stopped at this method implementing an attribute's value or incrementing an attribute's value through a method. So we all know what attributes are. Um, so let's just move on. I don't think that we have question. I think what brought some of the questions last week was about the misuse of word global, which I did. So when I was explaining about how to access variables declared inside init method, I use the word global, which brought some confusion to some of the students. So what I meant last week was when you want to access the variable here, you use the self that you declared here. So some asks, why can't we create the variable here? Because they have experience in the other programming languages when we have a class variable here. So let me clarify that the variable declared here is a class variable and it has a purpose. And the variable here usually termed as instant variable. It has its purpose. So one of the issue with the class variable here is that when you declare a variable here, all the instance of the class, all the objects share that variable. So even if you delete the object, so let's say we have a variable here. I think I do have one down or up. Okay, let me declare a variable here. Let's say we have a variable here. Let's say I am a class variable. Then I have a value here, just like 0. So when we have a variable like this, let me use small I here, just like this. So when you have a variable like this in a class, what this means, oh, sorry, I have a space here. So what this will do, let's say we have 0. So when you create object of this class, an instance of this class, what it does is this variable will be assigned 0. And imagine that you overwrite the value here using the object you created. Then when you try to re-access the object, you will see that the value is changed because this variable is shared. So that's the highlight. So let's move on to inheritance. So what inheritance is just like normal inheritance we have in real life. When your father has something, you can inherit it. So let's look at this diagram. when you look at this diagram, we have a class. Consider this as a class whereby this stands as the name of the class, while these are the attributes, while this one is the function. So name is an attribute, phone number is an attribute of a person, then email also characteristics of the person. We can describe person with name, phone number, and email address, because all of this can be unique to a person. Then, when we look at this, is another class. So student is another class, professor is another class. So can we say student is a person and professor is also a person? Yes, we can say that because student is a person, professor is also a person, and student can also have a phone number and email address. Same also applies to professor. Professor can have a name, can have a phone number, can have an email address. While other properties can be different, yes. So this can be of importance because it allows you to organize your program or your code so that it can be clean and less complicated. So what we are saying here, we don't always start a class from scratch. Sometimes when we have another class that has what we have, we can just inherit those that we want from that class instead of starting from scratch. So if you are writing a specialized version of another class you wrote, maybe you have a general class that has general things, and you have a specialized one, so you can inherit from the general. Yes, you can inherit from the general. So the general can be your parent. So in this sense, we use what is termed as inheritance because we inherit from a general class. So when one class inherits from another class, it takes on the attribute and method from the first class. So when you inherit, you possess everything from that class you inherit. We will see example shortly. And the original class, that's the parent class, is called the parent. You can call it a parent or base class because you are inheriting from that class. That's why it is the parent. It is the one who gives you something. Then the child class can inherit any or all of the attributes and method from its parent. So let's see the example here. So as you can see here, when we inherit from this class, it means that we can use all the attributes here in addition to our specialized attributes here. So we created a car class above. So look at what we have done. So graphically, this is our car class. This is the name of the class and the make, model, year, speedometer reading are the attributes of the class car. Then we have methods. We have this init method that we usually have. Then we have another method, get descriptive name. Another method is read odometer, update odometer, and increment odometer. These are all the methods in the car class. So if we have a specialized class like electric car, because electric car is a car. Yes, is a car. So all of the cars we have this general information, all of this information. But electric car has some specific information that is peculiar to it. So here, the car, that's the parent. You can call it SUFA, you can call it base, you can call it parent. This is the term we use to describe the parent class, the one we are inheriting, the class we are inheriting from. It's called SUFA class or base class or parent class. The class that is inheriting is called subclass or derived class or child class. So let's see an example here. This is our car class that we've been using for long. We have all the methods here. Look at this method. We have about 5 different methods here. We have 4 different attributes. So these are the attributes we have in the init method. So when you instantiate any object of this class, when you create an instance of this class or object of this class, so you should have this method. The object will possess all these attributes plus the method here, plus this method, plus all of these methods. So now we have a class. Let's run this so that we have it in the RAM so that we can. Yes, someone has question? Question? Okay, now we have our class and we have everything. We have method, we have these things. Now let's create another class. This is a general class. To give you an idea, maybe someone has a problem that he wants to model. We know in object-oriented programming, everything is object, and those objects can be related in one form or the other. Then what you should do, you should list all the properties of the objects you have. In that case, I mean the class you have. So this class has these properties, class B has these properties, class C has this property. Then you can use the concept of intersection in set theory. So you can say these objects share attribute with this one and this one and this one, because this and that object share this attribute. You can just bring it out and create a general class for that. Let's say you are creating a math class. Maybe you are creating a class that will help students learn mathematics very well. Then maybe you can say that a cycle and maybe a sector and maybe semi-cycle, arc, and maybe cylinder, they share radius, the term radius or attribute radius. So you can bring radius out and put it in one class. Maybe you can call it shape. So you can, when you want to create a specialized class, then you can inherit from the class called shape. So now we have this class. So now we have car, electric car. We already defined our base class, parent class car, which has general information about all the cars we have. All the cars have make, they have model, they have year, then they have odometer reading. All the cars we have in the world. So we have this function that can be used to describe these attributes. Then we have a specialized class that has something that other class doesn't have. So how do we inherit this? Then we have our own other peculiar attributes that we can define later. So let's start by inheriting. How do we inherit? We inherit by creating our class here. We start by using the keyword class. Then we have the class name. Then we open brackets and put the class we want to inherit. So if you have number of classes, you can separate them by comma. You want to inherit car, you want to inherit another class, maybe whatever, you can just list them. So here we are inheriting from the class car. That's why we have this car here. So when we do this, it means that we are taking all these attributes and this method so that we can use the object as the object of this class can use them. We can also use them here. But there is additional things. When you do this, to have the attributes, you have to use this keyword called super. The super refers to the parent method. That's this class method. And all the thing, when you do this, you are referring to this class. This super refers to the class car. So in the previous version, you can use the name of the class instead of using the word super. So some of you that are familiar with Java, they know this. They know this keyword, and even other programming languages like C# and many, they use this keyword super to refer to the parent class car here. So you call init method here using the car. Here is just like car here dot init method. Then here you put this attributes as this class also has them. It has the make, it has the model, it has the year. So you see the arrangement must be the same because this one go to the first method, this one goes to the second, this one
So
goes to
somebody is lighting up the screen. Silas just
yes, sure. Somebody is who is doing this? Can you please stop? Let's see whether I can delete it. Yes, I think we are good to go. Yes, someone has question.
Yes, thank you. Can you hear me?
Yes, I can hear you very well.
Okay, so just a quick one. So the car is a super class being passed to electric car, which is the child class, right? But in
Yes.
Python, what you're doing here is that I can see that you put the car as a parameter of another class.
Yes.
Instead of a keyword like extend, which or
Extends,
implement, which
yes. Yes, yes.
so you pass it as a parameter of a class, and then you
Yes.
set the constructor, the init method to the what do you call it, the attributes of the class that
The
you
parent
are
class,
creating.
yes.
Okay, so what if the child class you are creating has its own attributes? For instance, what if the child class electric maybe has a battery life or number of hours the battery lasts, and that is
Yes.
the additional method, or sorry, additional attributes that electric car has. How then do you set or initialize this attribute?
Yes, this is very, very good question. Because when you try to create an instance of this class, you will provide some of the data you want here in the init method. Therefore, you can just select if you want to pass some values as you create object of this class, you can just pass them. But here, when you are calling the parent class, because the parent class has the general information, but the battery life maybe is specific to this class, electric car, then you can just select the general information and pass it to the parent class. This is very good question. Yes. So this is how to do it. If you have additional method, you can do it. You can just write it here. You can define it here. If you don't, then guys, I don't
Yeah, I
think
was
that.
talking about additional attributes or yes, additional attributes. For example, battery life. Do you
Yes,
add
that's
it to
what
the
I'm
init
saying.
method?
That's what I'm saying. If you have battery life, you can just put it here. Battery life like this.
Okay.
If you have
Thank you.
additional, just put it. You understand? If you have any other additional variable, you can put it here. Maybe it has solar panel size. Any other attributes, you can put it here. But when calling the parent class, you can call it with the parameters that it needs, like this one. So the other one, you can just use yourself dot battery life. You understand? Just as you do, you understand? Then you have set
Understood.
whatever you have here. So in this way, you inherit from the parent class, then you have additional attributes here.
Thank you.
Okay,
Yes,
sir, please, I
Habari?
have a question.
Yes.
So, since we are inheriting those other attributes in this
Yes.
class using
Yes.
this super keyword and initializing the attributes, do we have to still initialize it in the first place? In this def init, do we have to initialize those attributes we already have, or we are already inheriting from the super class?
We are inheriting. What we are doing here, instead of rewriting.
So like this make, in the def
Yes.
init, this make, model, and year, do we have to still initialize it since we are calling it in this super init make, model, and year?
Yes, when we call this super.init, what it does, it initializes the variables for you here. Instead of rewriting this code, you see that when you call it, it will come here, this and this. It will just call this init method from, because look at this. We are calling the init method. We are passing this information to the init method. So when you call it here, when you call the init method, it will just assign the variable to this. You see, we have this, we initialize the variable with the value we supply when creating the object of the class. You understand? So we don't need to reinitialize.
Okay, yes, I understand.
Yes, when we pass the value, when we are creating the object, then we are done, because we don't need to redefine this function, because the function has already been defined in the parent class, so we don't need to redefine it. And again, we have additional other things that this car class has, because it has this method that can give us information about descriptive name. It has another method. We inherit both of these attributes together with the method here. So we don't need to waste time redefining this method as well as reassigning values to this attributes. So this saves our life, because we don't, once we define the class, we don't need to redefine this method, unless our method is different from this implementation. So in that case, we can use what is termed as overriding. So we can re-implement the method in our own way. That's overriding. So we will discuss, maybe when we come later, we'll discuss about overloading and overriding. Any
Okay,
other
sir,
questions?
thank you.
Yes, welcome. Any other question? So from this, we don't have any additional variables here. We don't have any additional constructors or parameters here. We just create an electric car because we start from somewhere. So as we keep coding, then we keep adding lines of code. Then, so here, when you inherit from this class, we can call this. Look at this method we call. So here, when we create the object of this class, electric car, we pass this information, Nissan, Leaf, and 2024. So this information will come here. For this year will come here, the model will come here, the Nissan will come to the make, then this will be sent to the parent class using this line. So the parent class will initialize these variables and we can have access to all the methods we have in the parent class. So here, because we already create the instance of the class here, then we can use it to access all the methods in the car class. Remember, we don't have any method get descriptive name here. We don't have it. But look at how we call it here. Now let's run and see what happens. Now you see, because we inherit from the parent class, now we can use the method here because this method has been defined in the parent class. So not only this method, this does not apply only to this method. You can access all the methods defined in the parent class plus your own specific or specialized method. So what the super does, super is just a function for a special, it's a special function that allows you to call a method from the parent class. So this is another class. So you can create as many classes as you can, but this class is for the parent class. Yeah, when you want to create an instance of the parent class, you can just do this, you supply the values, then you have the object, you have everything. So how do we define attribute and method for the child class? Maybe we have a general information from the parent class. Now we have our specific requirements that we have. Let's take, for instance, in a school settings, we can have students in the class, in the school. We can have undergraduate student. We can have graduate student, and we can have many other kind of student, maybe whatever. But they have information that is general or common to them, and they have their own specific information that they have. And maybe they can do something while others cannot do. Maybe a graduate student can be can have access to the lab while undergrad may not have access to the lab. So how do we define attributes and method for the child class or specific to the child class? So once you have a child class that inherits from the parent class, you can add a new attribute if you have one, and method if you have one, necessary to differentiate a child class from the parent class, because maybe the child class has something specific or peculiar to it. So let's see. Let's say we want to add an attribute specific to electric car. That attribute can be a battery, because and maybe a method report on this attribute, to report on this attribute. So we will store the battery size and write a method that prints description of the battery. So let's see this. Here we are creating an electric car and we are inheriting from car. As I keep saying, car has general information that this car has, but this car has specific information that is peculiar to it. So here we inheriting from the parent class or base class. Then here we call the init method from the parent class so that we can have this initialized. Then look at this. We have another attribute which the parent class doesn't have. So this is where to define it, as I already answered this. Then we have another method that the parent class doesn't have. So here, line 14, we are creating an object of the class, we are passing this information, then here we are accessing this method that is defined in the parent class, and here we are using the same object to access this method describe battery that we define in the electric car class. Is there a question? Any question before we go on? I know that some of you may have question. So let's run and see. Answer the question. So you see, this is the information we have. We call the get descriptive name. So it gives us this information. Then here, we call this method describe battery, and what describe battery does is, look at this, it prints a statement describing the battery size. So this is the statement that describes the battery size. This car has, you see how we access this value, battery size. We use this sub dot battery size, then we have this strings, kilowatt hour battery. So what we did here, we have just added a new attribute called battery size. And when creating the object of the class, we set it to have 40 kilowatt hour. Then this attribute will be associated with all instances from the electric car, but not from the car class. So if you create an instance of car class, it will not have this battery size. But when you create an instance of electric car, it will have this kind of variable. So this differentiates the two. And the describe method as well is only accessible by the object of electric car, while the object of car will not have access to this method describe battery. Now, another term in object-oriented programming is overriding method. Overriding method. So we override method from the parent class because we have our own method and we have or we possess or inherit method from our parent, from the parent class. So you can override any method from the parent class that doesn't fit what you want. So if the method defined in the parent class is doing different things, and what you want to do is quite different from the parent class, so you can override that method. You can redefine it. So when I say overriding, what I mean literally is redefining that same method to suit your needs. So to do this, you define a method in the child class with the same name as the method you want to override. So if the method you want to override is called set battery size, so you should define set battery size as well. So what Python does when you do this, the Python will disregard the parent class method and just pay attention to the class you define in your specialized class. The class you are inheriting, or the child class in another term. So now say, let's look at this example. So consider or assume that you have a class car that has a method fill gas tank. Fill gas tank. So if the basic assumption here is that the car class assumes that all cars has gas tank. That's why it has this method, fill gas tank. But an electric car doesn't have a gas tank. So in other words, it doesn't need this method at all. Or maybe the information that this method prints can be is not useful to the electric car. So this method is meaningless in short for all electric vehicles. So you may want to override the method because it is meaningless. So let's see this example. So we have this class, electric car class, and we are inheriting from car class here. Then we have init method as usual. So in the init method here, we call the parent class. Then here we have additional attributes, battery size, which we set to 40 kilowatt hour. Then we have another method, describe battery, which is peculiar to this electric car class. What this method does is print the statement about the battery size. Then here we are overriding the method fill gas tank from the parent class. So instead of just calling the method, we redefine the method here, which means we are overriding because this method already exists in the parent class and we redefine it. It means that we are overriding the method. So here what it does, it's print this statement. The car doesn't have a gas tank. Now here we are creating the instance of the class called myLive. Yeah, because we use electric car, we are creating instance of electric car instead of creating instance of car class. Then here we are accessing the method get descriptive name. Here we are accessing the method describe battery defined in this class. So when you want to access the other method, you can use, okay, let's run this first. So you see what we have. So when you want to access the other method, you can say my underscore leaf. Then we say dot, maybe fill gas tank. So fill gas tank doesn't expect any parameter to be fast, so you can just throw it as it is like this. So when you call the method, this is what we have. This car doesn't have a gas tank. So even if they are complex, this method already exists in the parent class. So this one will be called. So Python will neglect the other method. So sometimes when you code, maybe when you code a very big project, you start writing your code, I think, with one line. Yes, everyone knows that when you start writing code, you start with one line. But as you go, your code will get bigger and bigger and bigger. So sometimes to avoid that, you can break your class into number of classes so that your code can be manageable, so that you treat maybe some section of your code as just maybe as class. So in that case, we have what we call composition. So composition is a term that we use when we have very large class, but we can into or smaller classes. Maybe another class called battery. For example, maybe when we have the electric car class, we might notice that we are adding too many information in the class. We are adding too many attributes. We add this method, we add this attribute. And sometimes the class contain too much information that maybe become maybe not easy or easier to read. In that sense, you can just break the class into number of classes. So how do we do that? For example, we can have, for this class, we can have another class called battery. Instead of embedding this information in this electric car, we can recreate another class called battery. So what this does is it's just a class that attempt to model a battery of an electric car, because an electric car battery is vital for an electric car. So we can create a battery class for it. So for this, when we are calling this, so we provide information about the size of the battery. Then we have a method that describes the battery size. And here we have the electric car, which exists on its own, though it is related to the battery class. So for this, when we are creating the instance of the class, you see we provide the information about the year, the model, and the make. Then we can call this method, see, describe car, which is already in the electric car. Then here we are calling Tesla.battery.describe this. So why are we using this? Is because here we are using the instance of a class as an attribute. Remember how we create object of a class? What we do is we call the class here, literally, we call it here, then we have the instant here. So this literally the name of the class, then the object name here. So here we have an attribute, is another attribute, but contains all the information in this car battery, the battery class. So in that sense, we have the instance, then we have dot. So look at this battery, is the one that we are accessing here. It's the same thing as this battery. Then we can use this just like this. Consider this as an object, another object that has access to this method. So you can access this method only through this attribute. So let's run this and see what we have. So here I am defining the class as I am just running as because we have already defined the class. So let me run this. So you see what we have. Alaikum salam. No. Yes, so we have this, so we can have access to the description of the battery. So let's see. So let's round off by talking about how we model the real world objects. Because sorry. I'm sorry, I'm having a call. I'm getting distracted. So as you begin to model complicated things like electric cars, you wrestle with interesting questions. For instance, the one we've just finished here, the code we have just written here, we can ask ourselves a question. Is the range of an electric car a property of a battery or of the car? So this is the kind of question you will encounter when trying to model the real world object. But the very important things to always consider is whenever you want to model a real world object, think about the context. Think about the context. There was a time when we were having a lecture, our faculty asked us, I will ask you the same question. If I ask you, who is a student, what answer will you say? If I ask you to describe who is a student, when we want to maybe understand the term student, who is a student? Is anyone can volunteer so that we can have a discussion? Yes, Hassan Muhammad, who is a student?
Yes, sir. A student is a person who seeks for knowledge.
Yeah, okay. Thank you for this answer. Let me have another answer from someone.
Let me give it a try.
Uh-huh.
I think a student is a person who pays for registration or who register with the school.
Yes, very, very good. So let's start with let's discuss the first one. I think that when I allow all of you to give me the answer, everyone will say different thing, and I will disagree with all of you. So let's start with the first one. He says a person who seek for knowledge is a student. Can we have a school for animals, for dogs, like for pets? I think pet
No.
can be a student, just like, no, we have.
Oh,
Whereby
really?
you take your dog there, then they will teach your dog how to chase a thief.
Yes, yes.
So you say a person,
Very
student
true.
is a person, and seek for knowledge. Maybe let's think about another example. Let's say near your university, someone committed a crime, and maybe he used to enter your lecture. Maybe he used to go to your school and enter your lecture room and maybe listen to your lectures, but he's not a registered student and he seek knowledge. So is he a student in that school? Maybe he has committed a crime. And maybe someone is interviewing him and he said that I used to go to attend lecture in so school and he is not registered, but he seek knowledge. Is he a student?
No,
Yes, again.
He
Maybe
is.
someone,
He's a
okay,
student.
is a student where?
he's not.
So you see, so always we will have a disagreement. There is no, this definition can kill, this question can kill. You can spend the whole life searching for the answer. And if you say that someone who pays for registration fee, as explained by the second student, he said that a person who maybe pays for school fees, he get registered, but he stopped attending the school. Is he a student? He is not. So that's why modern was very complex. It's very complicated things that you can do, but when you know how to, then it will come as easy as possible. So it can happen to electric car. We can ask ourselves, is the range of an electric car a property of the battery or the property of the car? So if we were to only describe one car, it is probably fine to associate the method called get range with the battery class. So we associate it with the battery class instead of associating it with the car in its entirety. So however, if we are describing manufacturer's entire line of cars, it might be more sense, you see, more sense to move get range to the electric car class. So sometimes you need to think and rethink and rethink. So in this scenario, get range method will still check the battery size before determining the range, but it will report a range specific to the kind of car it is associated with. And as the author said, alternatively, we could keep get range in the battery class, but pass it a parameter such as car model. Yes, the method will then calculate the range based on both battery size and the car model. So you have a choice, either to do this or do this. But you need high level thinking in programming. So wrestling with this kind of question is a sign of growth as a programmer. So now you are growing, you are programming, and you are growing as we go. Because we started with procedural, then we now move to object-oriented programming. So you are beginning to think very hard. So your faculty of thinking is progressing to the higher level. So you are thinking at a logical level rather than just focusing on the syntax, because we have already covered all the syntax. You know how to declare a variable, you know how to declare a function, you know how to call function, how to instantiate class, how to inherit from other class. So next, what we are going to do, we are going to delve into, you write your class. Now you have another class. You have another class. Now, how can you have maybe like module, or you have a program, you have already have a predefined class that you want to import. So this is what we are going to do tomorrow, God willing, inshallah. So I think that's all we have for today. We are 22 minutes on top of the hour, though we have started late, but this is just the remaining of the previous class. Yes, Umar Zakaria, you have question?
Yes, sir. Good afternoon, everyone. Thank you, sir, for this wonderful session. Sir, I want to make an inquiry about the remaining update for this chapter 9.
Yes, I already uploaded it. I think like how many minutes? Like 30 to 40.
Okay.
Yes.
Okay. I checked it recently, but let me
When you read, you will
think
see.
on it. Thank you.
Updated it. Yes, I push it to my origin. I also push it to audio data science as well. I think, yeah, I put, okay, I follow the changes, then I push. And when you will see it. Yes, Hassan Muhammad.
Yes, doctor. It's just in relation to what you just spoke about, the real world scenarios that we are facing in terms of
Yes.
programming. I'm
Yes.
saying, will I be right if I said that this kind of definition of classes or instances or attributes depends rightly based on the criteria or the scenario that we're dealing with?
Yes, definitely. Yes, you always think about the context.
All right. Thank you very much.
Because if I ask you, in your university, you have all students, we call them all students, but are they students?
Of course, they are not.
Sometimes, are they students if they commit something, if they commit crime? Are they students? Will you refer them as your student?
It depends on the context you look
The
at it.
context. Yes, it depends on the context. So that's it. Depends on the context.
Thank you. Thank you.
Yes. So I think no any other question. So we can meet.
Sorry, sir, please, I have a question.
Okay.
It's regarding how to import modules.
Yes, that's I think next class.
Okay, sir. No problem.
That's tomorrow. We'll talk
Okay,
about
sir.
that.
Okay, sir.
Any other question? So no question. Let me just stop the recording and